Hi everyone, and thank you for joining us for our latest episode of Make It Mesh, the podcast series from Tetrate. I'm your host for the episode, Tia Louden, and this week I sat down with Tetrate engineer and Envoy contributor Yaroslav Skopets to talk about the recent work surrounding Envoy extensibility and Wasm. We cover why this was necessary and the work of another open source project, GetEnvoy, and its new Extensibility Toolkit. Enjoy!
Hi, my name is Yaro. I'm software engineer at Tetrate, Envoy contributor. My main focus of work is support for WebAssembly inside Envoy and providing developer tooling to help creating WebAssembly-based Envoy extensions.
So thank you for joining us, Yaro, and I guess we better get started. So why did Envoy need to be expanded to support Wasm?
It happens a lot that companies adopting Envoy run into a need of custom extensions, most often to integrate with the pre-existing infrastructure. For example, it's very common for organizations to already have in place company-wide solutions for authentication, authorization, logging, and if Envoy doesn't support integrations with those systems out of the box, you want to be able to do it yourself, and this is a perfect use case for custom extensions. Envoy has been designed to be able to handle any network protocol, so extensibility has always been there. However, because of technical constraints, it was less accessible to the end users. For example, you had to develop your extension C++, statically link it into Envoy binary, maintain your custom build of Envoy, keep this build up to date, which all means lots of maintenance burden. So Envoy has been looking for a better extensibility model, or at least alternative one, and WebAssembly is an answer to that.
And so before we dig any deeper, let's take a quick look, if you don't mind, at the history of Wasm. Where did this come from?
WebAssembly originated in web browsers. Web browsers were looking for a way how to execute application code faster than JavaScript would allow. The initial solution to that was called Wasm.js. It was a subset of JavaScript that browsers were able to optimize very efficiently. Applications were developed in a high-level programming language like C++ and then compiled or transpiled into Wasm.js for the purpose of execution inside a web browser. WebAssembly is essentially a second take on the same problem, with all the lessons learned from Wasm.js. Applications still developed in a high-level programming language like C++, Rust, Go, Lang, but when it comes to compilation, they get compiled into WebAssembly code instead of native code. WebAssembly has such important qualities as portability. It's possible to run WebAssembly code on any operating system or hardware architecture. It's secure and run inside sandboxed environment. All these qualities combined make it very tempting to build extension model on top of it, not only for web browsers, but for Envoy as well.
And what has this extensibility toolkit in GetEnvoy done to improve the developer experience?
Because technology itself is very new, the learning curve can be quite steep. The goal of GetEnvoy Extension Toolkit project is to make sure that you can start developing extensions in a matter of seconds. For that, we do provide you with a build of Envoy that has WebAssembly support, with SDK that comes with lots of documentation examples, with extension templates, and with GetEnvoy command line interface that you can use to bootstrap new extensions, build, unit test them, and run inside Envoy. Overall, it's meant to be the easiest way for end users to get started with WebAssembly-based Envoy extensions.
And this is a slightly different question, but what will this mean for users too?
In the same way we help extension developers to get started in seconds, we will provide similar experience to extension users. It will be possible to find extension and start locally for a demo using GetEnvoy command line interface. Users will not be required to have any prior knowledge about WebAssembly or Envoy configuration, just to be able to see extension in action. To make it possible, every extension developed using the toolkit includes runnable examples prepared and maintained by extension developers, which ensures that they always stay up to date.
And one thing we should mention at the moment is that Rust is the only language supported by the GetEnvoy toolkit. What's the reason behind that?
While any programming language could potentially be compiled into WebAssembly code, at the moment only C++ and Rust provide sufficient level of support. If you choose one of these languages, you will be able to use all features of the language, you will get performance you expect, and you'll be able to reuse libraries you're familiar with. We want you to be able to create featureful extensions as of today. That's why we choose Rust. In the future, we will add Golang as well.
So building on that, how is the Envoy SDK for Rust, which is part of the GetEnvoy extension toolkit, related to the proxy Wasm SDK? And as a user, how can I make a choice between the two?
I probably need to explain first what proxy Wasm is. Proxy Wasm is a low-level interface for interaction between Envoy extension and Envoy host. Historically, support for WebAssembly inside Envoy was developed for Envoy only. But along the way, it was decided to try to reuse the same model and the same API for any network proxy out there, for example for Nginx or Apache Traffic Server. The cost of doing this is that API has to remain neutral to any proxy in particular. And from developer perspective, it means that your journey starts from a question, how do I use this API to develop Envoy extension? So in contrast, the problem we're trying to solve with Envoy SDK for Rust is how to empower users of an Envoy to be able to extend it easily. From this perspective, proxy Wasm is just implementation detail. We offer concepts familiar to most of Envoy users and developers, such as HTTP filter, network filter, access logger, and provide guidance how to develop such extensions.
It sounds really exciting. Is this something that's ready to be used in production?
Well, I should probably say that my opinion is just mine. It's not the opinion of Envoy project or Tetrate. So I would say that no, it's not production ready yet. But in order to get to general availability, we need to start seeing adoption of WebAssembly-based Envoy extension by actual users. So it's very important for you, users of Envoy, to start developing such extensions and give us feedback how ready they are for use in production.
And what's next? What can we expect to see?
Well, I will need to refer one more time to the history of WebAssembly support inside Envoy. Historically, support for WebAssembly has been developed in the context of Istio project. That's why all the focus has been on meeting Istio requirements rather than being a general-purpose extension model for Envoy. If you compare APIs available for use by native Envoy extensions versus APIs available by use for WebAssembly-based Envoy extensions, you will see significant gap. So the next major step on the road to general availability is to eliminate this gap and make sure that almost any extension that exists today in upstream Envoy can be re-implemented using WebAssembly.
And what is your ask of the community right now?
MacLeod, creator of Envoy, has been repeatedly asked, why C++? And usually people who ask this question, they imply, why not Rust? So now we're offering you Envoy SDK for Rust, so your excuse is gone. So if you ever wanted to develop Envoy extension, now it's your time. Please give it a try and help us to get WebAssembly support inside Envoy generally available.
Thank you, Yaro, so much for your time and taking us through the work that's been done so far. I can't wait to see what's next. And if you're listening to this and anything that Yaro has said has piqued your interest, please try it out and give your feedback through GitHub. Similarly, if you want to get in touch and ask more questions, please reach out to learn@tetrate.io. Thank you so much for joining us, and we look forward to hearing from you, and join us next time. Goodbye.